Welcome to Highline BI 348 class video number 54. Hey, if you want to download this workbook, BI 348 Chapter 5, and follow along, click on the link below the video. Hey, last video we talked about charting a time series to help us pick the right forecast method. Now in this video we're going to start on the sheet Basic Forecast, and we're going to talk about different ways to forecast and different ways to measure forecast error. Now we're actually going to start over on our PowerPoint, so you can download this file also. Forecast is simply predict future values based on past patterns. Now there's a caveat because forecasting is about the unknown future. So although we try to forecast accurately, we never know if the patterns we have seen in the past that we are using to make the prediction will hold into the future. Not only that, but you never know what will happen in the future. Hey, a couple famous people, Yogi Berra in particular, said it's tough to make predictions, especially about the future. Now that's a little bit funny, right? But it's true. We actually don't know what's going to happen. So we're going to do our best. We're going to use past data to predict the future. But if those patterns from the past don't hold, then our predictions are not going to be very good. Now I want to go to slide 10 to talk about different methods for forecasting. We're going to talk about in this video the naive method, or most recent, averaging of past values, moving averages, and exponential smoothing. We'll see all four in this video, and we'll use the same data set and see which one, in fact, is more accurate. And the way we do that is next slide. Forecast accuracy or forecast error, whichever way you want to look at it. And we're going to look at four different measures: mean forecast error, mean absolute error, mean square error. That'll be the main one that we use to compare different methods. And then a relative measure called mean absolute percentage error. All right, let's go over to Excel. Now we're going to use the same data set, 12 months. That'll be the time variable. And then the sales in $1,000. We're going to use the same time series for our four different methods. And the first one we're going to look at is the naive method, or the most recent forecast method. And you can see over here we plotted this, and this looks like a horizontal or constant time series. Now it's going to seem strange here because forecasting, what is forecasting? Well, we know 12 periods, right? And we really want to estimate the 13th. But once we estimate this 13th, we actually can't measure if that's accurate because it's about the future. So the way we measure forecast accuracy or forecast error is by using our method on a bunch of past values and then measuring what the actual error accuracy is. So this is going to seem strange at first, but we'll try and get the hang of it. Now, the most recent is very simple. For period number 2, if we were sitting in period number 1 and we wanted to forecast the next period, we just use this value. So the naive method, or most recent, is, hey, for period 2, we're just going to get the value from the past. Control-Enter, and copy it down. That becomes our forecast. Now, we're going to use this and do a bunch of steps to measure the forecast accuracy or the error. But estimating for the next month, month number 13 right here, we simply say, hey, we're going to take month number 12. Now, if you look over here to our chart, you can see that it's pretty choppy, right? Because we're using the actual value from last period. So in this period, even though our value turns out to be 25, our forecast was 30 because we used the value from the last period. Now, in subsequent methods down here, our next three methods, this forecast will be much less choppy, and there will be less forecast error. One thing you can say about the most recent, if it jumps to a new level, of course, this method would adjust quickly, whereas methods of averaging don't adjust quite as quickly. Hey, let's calculate our forecast error. And this should seem similar to what we did earlier in the class, where we calculated standard deviation, like we took particular value minus x bar. Or we calculated errors for linear regression, particular value minus the linear regression predicted value. Well, here for forecast error, we're going to take the particular value minus our forecast. All right, so you can see it's positive 4. That means we took our actual value, subtracted the forecast. Our forecast is actually under predicting. We get a net of 4. When I copy this down, we're going to get some plus and some minus. Because if it is a random fluctuation around the mean like this, then some will be above and some will be below. Here, minus 5 means the actual forecast method over-predicted. Now, for our first measure, we simply add up all the forecast errors, Alt equals, and then Enter. And now we want to calculate a type of average, and each one of these measures will be dividing by something. Now, notice we can't divide by the count over here because this is 12. So we need to actually divide by 11. And the way we do that is we say n equals the count. So I'm going to say the count of all these. And our k is going to be the number of periods at the beginning where we didn't make a forecast. And I'm actually going to do this in a very strange way. I'm going to use the rows function. And now I'm only going to click on one cell. How many rows are there for cell C4? There's only one. Now later, we'll have multiple periods at the beginning. And so we'll simply highlight it, and we'll tell us, the formula will tell us how many rows there are, even though there's nothing in that cell. So of course, we're going to get 1 because there's only one period we didn't make an actual forecast for. So n minus k will be our denominator in each one of these calculations here. So I'm going to say equals n, the count of all the time series, minus the number of forecasts we were not able to make. And so we get 11. So for our mean forecast error, we're going to say, hey, the total of all the errors divided by our n minus k. Now, there's one big drawback to mean forecast error, of course. That is some values will be above and some values will be below. So as you add these, they'll tend to be an offset. So of course, earlier in the class when we calculated deviations and residuals, we always tended to square them. Our next measure is going to be called mean absolute error, or sometimes not in our textbook, but in other textbooks, they'll say mean average deviation. And simply, we take the actual error amount, and we want the absolute value. So we use ABS. Control-Enter, and that tells us the distance from 0. Now we can add them up. There's the total of the absolute value for all of our forecast errors. And now we simply take that amount and divide by n minus k. Now, we could actually go over to our PowerPoints for a moment if you want. Slide number 19 has a formula for this. There it is, mean forecast error. We sum everything up from time equals k. Remember, k was 1, so k plus 1 means 2. So you go from time 2 all the way to n, all of your errors. E sub t is the variable we use to stand for forecast error. And then we divide by n minus k. Next slide is mean absolute error. We do the same summation of our errors, except for boop, boop. We take the absolute value and then divide n minus k. Back over to Excel. Another measure, and the one that we're going to use most often to compare different methods, is we're going to start by squaring the error and copying it down. Then we're going to add it up, Alt equals. And then we're going to take that total of all the squared forecast errors and divide by n minus k. And so we get 16.67. If we look at our formula over in our PowerPoints on slide 21, there it is. The sum from period, in our case, 2 to n, there's the error squared divided by n minus k. Back over to Excel here. So mean square error and mean absolute error, these are actual measures, a type of average of the error. So really, these are a measure of errors. But the lower both of these are, the more accurate the forecast method will be. And what we will do with MAE and MSE is we will compare these two to our other 3 forecasting methods. And in particular, the mean square error we will compare, and whichever one is lowest, that's the forecast method that we will use. Now, there's a problem with mean absolute error and mean square error. If we were to compare these measures of error or accuracy to a different time series that had a different time period like day or year, we couldn't do that. So what do in that case? We create a relative measure. So for percentage error, I'm simply going to take the forecast error and compare it to the actual value. So equals the forecast error divided by, hey, the actual value. Control Enter. And when I copy this down, I'll get some that are negative and some that are positive. I'm going to add this up, but of course that has the same basic problem. There's some offsetting of the pluses and minuses. So we will take the absolute value of those percentages, ABS, Control Enter, and copy that down. Now once we have all of the absolute values of the percentages, we can add those up. Alt equals, there's the total. And for mean absolute percentage error, we say equals, hey, the sum of all the absolute values for the percentages divided by n minus k. And that will be a relative measure. So now we can compare the accuracy of this forecast method for months to, say, a forecast method that was day or years. Now, mean square error is a measure we're going to use in particular when comparing different methods. So instead of using a formula like this, which is looking at the count and the sum and a whole column of forecast error squared, and then over here we're actually taking the difference between particular value and forecast for a whole column, we want to see how to do that calculation in a single cell. And the reason why is oftentimes we have the actual values and the forecast method, or maybe various forecast method. And so for each actual values and forecast method, we want to be able to calculate mean square error. And we can do that. We talked about this in the prereq class and earlier in this class. Anytime you have a series of calculations like that, which is then followed up by this one and then this one, you can start with the very first one and work your way backwards. So watch this. I'm going to simulate this whole column right here. And I'm going to use the sum product function. Now, sum product, the product part means multiply. The sum part means add. We've done this earlier in the class where we took multiple arrays and multiplied and added them. But we also noted that if you use just a single array, this function sum product can handle array operations without any special keystroke. And our single cell calculation will involve an array operation. Now watch this. I'm going to take the entire set of values, same number as number of forecasts. And notice that's a whole range of values or an array of values. Then I'm going to do the math operator minus. Right now, as soon as you have not a single cell, but an array of values or a range of cells in some operator, you're doing an array operation. Then I'm going to say, hey, the actual forecasted values and subtract that whole range. Now, if we highlight this and hit the F9 key, notice I just simulated the entire column of forecast errors. 4, minus 4, 4, 5, minus 5. There it is, 4, minus 2, 4, minus 5, all the way down. So right now I've eliminated that extra column. Now I'm going to Control Z. What do I do with the errors over here? I square them. So I'm going to do my second array operation, which is take the result of that subtraction array operation and then caret 2 to square it. Now it'll do a second array operation squaring all those here. I'm just going to click that, F9 to look at it. And there I've simulated this entire column. So 16, 4, 16, 25, 16, 4, 16, 25, all the way down. Control Z. Now I can simply, to get that value right there, close parentheses, and the sum part will add. Again, this is using the sum product function just because it can handle array operations without any special keystroke. If we didn't use sum product, we'd have to use the sum function and a special keystroke, Control-Shift-Enter. But I can simply enter that, and that's the numerator part. F2, now I need to do n minus k, but I'm going to be smart about this. N minus k is simply the count for the number of forecasted values. And I'm going to divide, and then I'm going to use the count function, and I want to count the actual number of forecasts that we made in the first place. And that really is the meaning of n minus k. Now remember, the point of this formula is that we wanted ranges to make our final calculation of MSE only from the column with the actual values and the actual forecast values. So when I close parentheses and Control Enter, boom, there we go. All right, now we're going to go down and do our next forecasting method. And then after we complete all four, we'll compare and contrast. This is called averaging past values forecast method. And what we want is here I need to take the first value. When I get down here, I need to average 24 and 28. When I get down here, I need to take the average of 26, 28, and 24. So when I get all the way down to the last one, that cell right there will average all of these. So instead of doing that manually, there's an easy way we can use the average function and a special kind of range. Now I'm going to click in the very first cell and then type a colon, which brings in the cell reference, the same cell reference a second time. And then I'm going to close parentheses. Now, I'm not going to copy it down yet. I'm going to put my cursor touching the first cell reference and then hit the F4 key to lock just the first cell reference. Now notice that the dollar sign is in front of the 27. But this 27 does not have a dollar sign. That means as I copy this formula down, that 27 will turn to 28, which will include that one. Then to 29, which will include that one. It's called an expandable range. Control Enter and copy it down. And you can go to any cell and hit F2. Notice it's expanded, and there's that 28. The dollar sign in front of the 27 stops the 27 from moving. No dollar sign in front of the 28 means when I hit Enter and F2, that moves to a 29. So all the way down, any cell you pick, that's called an expandable range. And that is another way to forecast. Now, if we look at our chart over here, we can see we're already getting a smoothing effect. The actual forecast, because it's not up and down, we're probably going to get a much smaller forecast error. Now, let's come over and calculate our forecast equals, I'm going to take the actual particular value minus the forecast and copy it down. I will definitely get some that are positive and some that are negative. Alt equals to add it up and Enter. Now I come down here, and whoops, I have to do equals count. Counting all the values, that's the N. K equals, and I'm still going to do that strange little rows. We still haven't seen an example where that's kind of any benefit. But that'll give us 1 here. N minus K, that's the number of forecasted values. All right, so now I can come to mean forecast error equals, hey, there's the total of the forecast errors divided by N minus K. Again, that has a problem because the pluses and minuses tend to offset. So we're going to use the absolute value function to get the absolute value. Control Enter, copy it down. And I'm actually going to take that formula, which is adding up the 11 cells above me, and copy it over. That way I don't have to keep doing Alt equals. Now I can come to mean absolute error equals the total of all the absolute values of errors divided by N minus K. And there's our mean absolute error. And you can already see, as compared to our naive method, it's a lot smaller. Mean square error, I'm going to come here, equals forecast error, caret 2, Control Enter, copy it down. Now I can come here, equals the sum of forecast errors squared divided by our 11. I'm going to do the same array formula as practice. We're going to take sum product. Why? Because it can do array calculations without Control-Shift-Enter. Open parentheses, I take the actual values, the same number of actual values as there are forecast values. Array operator minus, and I highlight all of the forecasted values. Close parentheses, caret 2, there's our second array operation, close parentheses. divided by count. And I'm going to count the number of forecast values. Again, the idea behind this formula is that we don't want to have to eventually do all these calculations, but we want a method for calculating mean square error only from the original values and our forecasted values. Control Enter. So we can see mean square error, 810 compared to 1627. So far, that's the method we're going to prefer. Now, if we wanted to calculate our percent error, there's the forecast error divided by our actual sales. Copy it down. Now I come over here and calculate equals ABS, the absolute value. Copy it down. Now I can come over here equals the sum of all the absolute values of those percentages, and I divide by 11. And there's our relative measure. Now we can clearly see this forecast method based on our past values has a much smaller mean square error, so we would choose this one. And our forecast would be equals, and it's the average of all the past values. And so there we go, 26.25. So we have an estimate here of 26.25. We can see it there. Our previous method was 29. We can see it there. Now we want to think about this average here. Notice we just took all of the values. Now, one disadvantage to doing this is if there is a sudden change in level, then this method will be slow to pick it up, whereas the recent method will almost instantly pick it up. So instead of averaging all of the past values, we're going to talk about our third method, which is moving average forecast method. And it's pretty straightforward. We're just going to say we're always going to average the last 3 values. That way, if we have a change in level, this method will pick it up much more quickly than averaging all the past values would. I'm going to start off by equals count all the values. And when I hit Enter, this is where equals rows is going to be a benefit. I need to get the information about how many values we're missing, and I don't want to type the number in. So I'm simply going to highlight these 3 empty cells, and rows will say how many rows are there from 51 to 53. There's 3 of them. So now we can calculate equals our n minus our k, and that is 9. That'll be our denominator for all of these calculations. All right, so the forecast, it's pretty straightforward. We just use the average function. And very carefully, you don't want to include the one in the current period, because this is the one being forecasted. We want the last 3. Those are relative cell references. As I copy this down, it'll always look at the 3 previous values. So when I copy this down, you can see at any particular time, it's 1 over, and it's got the 3 above. So in the very last period, sure enough, the 3 above. If we were going to do the actual forecast for period 13 equals average, well, we're just going to look at the last 3. And there our forecast would be 3. Now our forecast error equals, there's the particular value minus our forecast using moving average. When I copy this down, Alt equals, and I'm going to copy this one over right now. Oh, looks like we're getting 0. We don't even need to do this calculation, but as a template, we're going to say, hey, equals 0 divided by 9. Now, I'm actually going to lock that with the F4 key, because this formula, as I copy over, will always take the whatever the total is from above and divide it by that n minus k. So I'm going to drag this over here. Absolute value equals ABS, and copy it down. And so there I go. There is the total already done, and there's the division divided by n minus k already done. So 2.66. Squared error equals, go get our forecast error and square it. Control Enter, copy down. Ooh, and there's our mean square error of 10. So for comparing, averaging all the past values, averaging just the last 3, it looks like for this particular data set, that 810 mean squared error is going to be smaller. So we would use averaging all of them. Now, we'll see an example. All of these data sets will look like they're pretty constant horizontal. We'll look at all 4 methods with a data set that jumps in just a moment. Now, when we want to do our formula for mean square error all in one cell using SUMPRODUCT, we want to do the same calculation, except for notice we're only going to highlight 9 of the values and subtract our actual forecasted values, caret, close parentheses, caret 2, close parentheses, and divide by the count of the actual values that have been forecasted. There's 9 of them. And then I'll get exactly the same thing. Our percent equals the forecast error divided by our actual value. I can copy that down. Equals ABS. Control Enter and copy it down. Now I can come here. I'm actually going to copy Control C and Control V. And of course, that one will work. So there's our relative measure. And we can see here, we started here, and it looks like it's pretty smooth. Now, it looks like this one's probably a little bit smoother. And we can definitely see the error. But again, this moving average will pick up any changes in levels more quickly than averaging all of the last ones. Now we want to look at our last method here, exponential smoothing. And it's a type of weighted average. We're actually going to have our first forecast value looking at the most recent, but all subsequent forecasts will be a weighted average. We'll have what's called a smoothing constant, or alpha. Right here I have it set at 0.4. But this number can go from 0 to 1, and it will weight. It'll actually weight the past particular value a certain amount and the past forecast a particular amount. And what we'll do is we're allowed to change this after we create all these and adjust it until we find the mean square error. So the way this works is equals, and I'm going to take the last particular value, and that's a relative cell reference, times the weight, F4 to lock it, plus the past forecast value times, and it's the complement of alpha, the smoothing factor, F4, close parentheses. Control Enter, and copy it down. Now, if we think about this, right now, what this is saying is this little bit is saying I'm going to take 40% of that. And this little bit is saying I'm taking 60% of that. So I want to change this value, and I'm going to start at 1. And think about that. If this smoothing factor is weighting this, if I change this to 1, that means 100%. It's exactly like the naive method. Hey, only look at the most recent. But as I decrease this, it increases the percentage that the past forecast is taking, and it will smooth the line. So I'm going to change this to, and before we change that, look over here. We see the line. It's exactly like our most recent forecast or naive method. Now, when I change this to 0.8, you can see it sort of starts to smooth out. 0.5. You can see these values here, and it's smoothing out. Now, if I go to 0.4, smoothing out more, 0.2. And what I want to do, instead of looking at the line and eyeing it, I now want to create mean square error. And I'm not even going to bother with these columns. I'm just going to do our one single cell formula that looks at the actual values and the actual forecast. So you ready? Equals SUMPRODUCT, open parentheses. I'm going to do the actual particular values, exactly the same number as the number of forecasts we have, minus actual number of forecasts, close parentheses, caret 2, close parentheses. That'll give me the total of the square forecast error. But I need to divide by the number of actual forecasts. I'm going to use count. Control Enter. There's the mean square error. And as I change this, 0.5. Whoa, it looks like it went up a lot. 0.05, that would be a 5% weight for the last particular value and a 95% for the last forecast. Now, that looks like it's 10. 0.15, 15. 0.2, somewhere around 0.2. Now, actually, I'm going to show you a cool trick. Next chapter, we get to talk about linear programming and use solver feature. But we're going to use the solver feature to tell us when is this exactly at its minimum value by changing this input cell? Because remember, this formula is looking at all these values. This formula is looking at those values and this. Now, earlier in the class, we saw goal seek, where we could point to a formula and say, hey, I want that to evaluate to a particular amount by changing an input cell. Here, I'm going to tell Solver, change this to not a particular amount, but the minimum possible by changing this input. So you ready? It's under data, and we've been using data analysis a lot. Let's use Solver. Now we're going to do a very simple example here. Set objective, that's the cell. What do we want to do to this? Now actually the default is max. I already had it on min, but we set it to min. And then it says, and this comes empty, it says by changing what cell or cells. Later we'll see how to actually change a number of cells. I'm going to say just that cell. And using Solver for just this simple example, that formula, min amount, by changing that when I click Solve, it says, hey, Solver found a solution. I'm going to click OK, and there it is. That's the smoothing constant that will minimize our mean square error. Now, our actual estimate for period 13 would be, hey, I'm going to take the most recent times our smoothing factor plus the actual previous forecast times the complement of our smoothing factor. And that is our forecast right there. Now, down here, you can see I've listed our 4 methods. So our forecast for each method, and then our mean square error. And we can see 810 means that the averaging all of the past values forecast method, that will give us the smallest mean square error. Now, that's given that we have this data set, a horizontal constant data set. Now, when we come back in our next video, we're going to go to the sheet basic forecast 2. We're going to have a summary of all 4 of these methods, but we're going to have a different data set. And we'll see that using mean square error, we can pick an appropriate forecast method. All right, we'll see you next video.